All right. So the second part of Unit 3 trig is solving trigonometric equations, and it's really quite similar to solving algebraic equations in general. So a lot of the equation solving you did in Algebra 2, even in Algebra 1, you're going to be able to use. It's just the very last step. We have to use our trig tables and know where things are positive and negative, and things that we needed to know back in Unit 1. So here's some discussion on solving trig equations, which apparently is more fun than Parcheesi, but less fun than Old Maid. Yeah. Here's just a couple non-trig equations, just algebra equations. The first one, example 1, is a simple linear equation, x to the first power, so that would be linear equation. All you do is solve for x. And the reason that I throw this one at you is because if all you have is a sine of x, or a cosine of x, or a tangent of x, you don't have a sine squared or cosine squared, you're going to solve it pretty much exactly like example 1, except for the very last step. You don't have to do anything fancy. Now example 2 is a little trickier because it's a quadratic. It's got the x squared in there. Now there's two flavors of quadratic. There's the kind that have an x squared but no just x to the first, and there's the kind that have the x squared and the x to the first. And the kind that just have the x squared but no x are the nice ones, because all you do is basically solve for x squared and then take the square root. One thing that you really got to get down, this is something that catches people every single year, is when you get to the last step and you're ready to take the square root here, when you take the square root of an equation, when you're solving an equation and you take the square root of both sides, there will always be two roots. Because, wow, it's kind of hard to see it with 1/3, but let's say we took the square root of 9. Well, 3 times 3 is equal to positive 9, but so is negative 3 times negative 3. So whenever you take the square root in the process of solving an equation, remember both roots. That's going to be really important. Okay. Now, what if there's an x squared and an x term, like this guy or like this guy, right? Well, then we have to use a different style of solving. Once again, you did this both in Algebra 1 and Algebra 2, but we're just kind of reminding you. And it uses the zero product property, which says that if you multiply two numbers together and the product is 0, then either one of those or both of those values must be 0. And that's the only way to multiply to get 0. You have to have at least one 0 in there. And so if we have an x squared and an x term, what we can do is we can set our equation equal to 0, we can factor it, and then use the zero product property. Set the equation equal to 0, factor it into the two different terms, boom, boom. One of these two things has to be equal to 0 if our answer is equal to 0. What makes 0 equal to 0? Oh, 0. What makes x plus 1 equal to 0? Negative 1. And so you have two different answers in that case. This one is not set equal to 0 yet. Right? So we add 2 to the other side. Now it's set equal to 0. Now we factor it. This is kind of part of the review that we did yesterday, which is now on the YouTube channel, so you can check that out. Factor the trinomial into two binomials. What makes x plus 2 equal to 0? Well, that would be negative 2, wouldn't it? What makes x plus 1 equal to 0? That would be a negative 1. I'm not going to make you guys show this intermediate step right here. I'm going to assume that especially for a lot of these real simple linear factors, you can figure it out. However, if you ever get stuck and you can't figure out what makes a term or a factor equal to 0, set it equal to 0. It will solve the answer for you. If you set it equal to 0 and solve it. So that's a review of non-trig equations. Now we're going to do some trig equations. Like I said, there's one difference with the trig equations, and it's the last step, the very last step. And you need to know your trig tables and your trig ratios at exact values. What are you talking about, Mr. Yancey? You're talking like Egyptian or something. Well, I didn't sleep last night at all, actually, so I probably am not making a ton of sense. However, I can promise you that you do need to know your table of values, exact unit circle values. And if you go to page, 3-7 of your new unit, your new course pack, you'll find a couple practice tables. And you probably haven't done one in a while. You didn't really have to do any last unit in chapter 2 because all the graphing stuff, other than the very first couple days when we were plotting these points, we didn't use this much. So if you don't have forgotten how to do the table, you may want to go back and review that. If you go to the YouTube channel, I do have about a 5-minute video that goes through filling out the entire table. That might help if you have forgotten how to do it. But I'll leave those 2 practice tables completely up to you to make sure you still remember. You will, not on the quiz on Thursday, but on the next quiz, quiz 4, which will be sometime next week, probably I don't know, Tuesday or Wednesday-ish of next week. You will need to know your values, and you will have a blank table that you won't have to, but you may need to fill it out to help yourself out next week. So we're not going to go ahead and do this little practice today, just because I'm not here and it doesn't really make sense. But you guys do it on your own. Make sure you still know how to fill out the table of values, because you're going to see where we use it right now. Your homework assignment is going to be pages 8 and 9, and I'm actually going to do some problems from pages 8 and 9, so I'm going to do some of the problems for you. That'll cut down on the number of problems you actually have to do yourself, but it'll be good examples of the types of problems you'll see on this assignment. Use the following ideas when solving trig equations. So here's some guidelines before we jump into these examples. Number 1, set the equation equal to 0. Well, if it's a linear equation with only an x, or there's an x squared but no x term, no x to the first term, then no. And so that's why I said only if the x term is present do you need to set it equal to 0. Anytime you have a quadratic, though, and there is also an x term or a cubic or beyond, then we're going to definitely have to set it equal to 0. Then you completely factor the equation. Then you use that zero product property, and solving the trig function, instead of solving an algebra equation for like x, you're solving for sine of x or cosine of x or secant of x or whatever. And then at the very end, this is the one thing that we need to do that's different from solving all those algebra equations. We have to go to the table to figure out what angles are the answers, because remember, these variables, because they're inside of trig functions, are angles. So we have to figure out what angles they're asking for. So it's going to be very important to remember where sine and cosecant are positive and negative. Well, they're both based on y, so they're positive in quadrants 1 and 2 above the x-axis and negative below. Cosine and secant, right, based on x, so they're positive to the right of the y-axis, negative to the left. And then tangent and cotangent, which are based on both x and y, are going to be positive where the signs are the same, like positive, positive, negative, negative, quadrants 1 and 3, and then where you have one of each, they're going to be negative. So we do need to remember that, very important information from Unit 1. Let's get these examples going, huh? This is problem number 1 from page 8. So if you want to open up your book to page 8, your packet to page 8, you can do this one with me. This is probably about the simplest one you could possibly see. It's a linear problem. So all we have to do is solve for cosine of x. Subtract 1 from each side, right? And then divide by 2. So what this equation is asking is, where is cosine, what angles does cosine have a ratio of -1/2 at? So all of these answers are going to be ratios from the table. And so what we're going to do is we're going to go to the table and we're going to say, okay, let's see here. Here's cosine. Here's 1/2. It looks like we're going to be working in 60-degree angles. Now, here's one thing that you're going to have to keep in mind. Technically, there are infinitely many questions to these answers, because of coterminal angles, you could go around the circle in either direction infinitely many times and continue to get answers, which is why if you pay attention to the directions, it'll always limit you to usually one rotation. So in this case, if you look at the top of page 8, it says between 0 degrees and 360 degrees. So first of all, it tells you what interval you're taking your answers from, but also it tells you what to write your answers in. We're going to write our answers in degrees. Sometimes we do radians, sometimes we do degrees. So the only thing left to determine is where is cosine negative. What quadrants does cosine have a negative ratio? We know that there's going to be 4 reference angles for any of these guys right here every single time, because there's 1 reference angle in each quadrant. So, you have your 60 degrees, right? And then 180 subtract 60 is 120 degrees. That's your reference angle right there. Yes. And then we have our, sorry about that. Put 60 and 120 back in. Then we have, of course, 240 degrees, which is 180 plus 60. And then finally we have 360 degrees, subtract 60, which is 300 degrees. Those are the 4 reference angles that are 60-degree reference angles. Where is cosine negative? Well, cosine is based on x. X is a negative back in quadrants 2 and 3, behind the y-axis, to the left of the y-axis. And so our answer here is x is equal to 120 degrees and then comma 240 degrees. Those are my 2 answers. So you can see that if this was an algebra equation and there was no cosine, we'd be done right now. X is equal to negative 1/2, and we go to the next problem. Well, this is a trig equation, so when we get to this last step, it's not really the last step. We now have to reference the table to see where the answers are coming from. Confused? Well, let's do another example, and maybe you'll start getting used to this process. This is problem number 5, and this time we actually have a square, but we don't have just the x term, so this one's actually pretty simple. What I can do is I can divide by 2, right? And then I can take the square root. Now remember what I told you. Anytime you take the square root of both sides of an equation, you have to get positive and negative roots. There's always going to be those 2 answers. The square root of 1 is 1. The square root of root 2, or the square root of 2, I'm sorry, is root 2. We generally like to rationalize these, don't we? And so where is the sine of x equal to a positive or negative root 2 over 2? So we go to our table of values. Sine is the function this time, and root 2 over 2 is the ratio. And as you can see, we're dealing with a 45-degree reference angle. So our 45-degree reference angles would be 45 degrees. 135 degrees, that's 180 subtract 45. 225 degrees, that's 180 plus 45. Or 315 degrees, that's 360 subtract 45. Those are all 45-degree reference angles. Those are all 45-degree angles to the x-axis. Which ones do I want this time? Well, surprise, surprise, I want both positive and negative reference angles this time, right? Both positive and negative. There we go. There's our little highlight, right? And so we're taking them all. Okay, if we want both positive and negative, we know that the sign, which is y, is positive up here, so I want those, and it's negative down here. So if it was only the positives I wanted, I would take these 2 up here. If it was only negatives down here, but since I want both, our angles have to be 45 degrees, 135 degrees, 225 degrees, and 315 degrees. Okay, there's your answer. It's nice to box your answers. Let's go on to the next example, which is number 9. We're still on page 3.8. Now, the nice thing about this one is it is a quadratic, but it's pre-factored for you. And I think that's the thing you'll find about most of the problems on page 8 is either they're easy quadratics that don't have x terms, or they're pre-factored. I guess, yeah. I guess pretty much every single one of them fits that description. So page 3/8 is kind of the nice ease into this kind of a problem thing. But what we do need to do is we still need to use the zero property, because we're multiplying two terms. We're multiplying this term right here by this term right here. And the answer is 0. And so the zero property says one of those two things is going to have to be a 0. So what makes tangent of x equal to 0? And what makes tangent of x subtract 1 equal to 0? Those are our two questions. Well, tangent is equal to 0 at 0 degree reference angles. And so we're going to say that our 0 degree reference angles are on the x-axis, which would be 0 degrees, 180 degrees. And normally we go to 360 degrees, but you really have to pay attention to the details. And in your in the directions up at the top of the page, this is the exact notation for what it says to take your answers from. Notice that the 0 gets the square bracket. That means we include it. Unfortunately, or fortunately, I guess it doesn't really matter, but the 360 gets the parenthesis. That means we don't include it. And we go up to 360, but we don't actually include 360. So this is like right here, greater or equal to 0. And this is less than, but not equal to, strictly less than 360. So really pay attention to your brackets so you know when to include numbers at the ends and when not to. So we do not include 360. What about this other dude? Well, if I add 1, I'm really asking where is tangent of x equal to 1? And if we look at tangent again, and we say where is it equal to a ratio of 1, this time we're talking about 45 degree reference angles, and the 45 degree reference angles are 45, 135, 225, and 315. Where is tangent positive 1? Well, tangent's positive in quadrant 1, and in quadrant 3. So our answers for that part of the equation is 45 degrees and 225. Why are we not taking the other two reference angles? Because we don't want tangent to be negative 1. Negative 1 doesn't give us a 0. Negative 1 minus 1 would be negative 2 up here. And that does not produce a 0. Now, the one thing that you do have to do, I know it's a little bit of a pain, but when you get to the very end, you have to write all of your answers together in ascending order. Ascending order. It's just a notational thing. And it adds probably 30 seconds to your problem. So sorry on behalf of whatever Trig people came up with that idea a long time ago, but that's what they did. Okay, look at problem 10. Problem 10 is a little tricky because it doesn't just have one function. It has some sine squareds and some cosine squareds. And so, here's the way around that. There's actually a couple ways around it, but here's what I think is the better way of doing this, because this will help you down the road in a lot more problems. We're going to use substitution. And so we're going to, it doesn't really matter which side you do. We'll just stay with sine squareds, and we'll turn the cosine squared into 1 subtract sine squared. That's a Pythagorean identity substitution. That's all that is. And then we can distribute the 3 such as that. We'd add the 3 sine squared over to the other side. So what would that be? That would give me 4 sine squared is equal to 3. And then we could divide by 4 to get sine squared of x is equal to 3/4. And then finally we'll take the square root. And we will end up with the sine of x is equal to plus or minus, positive or negative, root 3 over, now the square root of 4 is just 2, right? So where is sine equal to root 3 over 2? Here's sine. Here's root 3 over 2. Oh, 60 degree reference angles. Cool. What are the 60 degree reference angles? 60 degrees, 120 degrees, 240 degrees, 300 degrees. Which ones am I going to take? Well, because I'm taking positive or negative, I'm going to take them all. And so your answer would be 60 degrees, 120 degrees, 240 degrees, 300 degrees. We'll take both the positives and the negatives. Now, I did say that that's one way of doing this problem, and I think it's the safer way because there's going to be problems down the road that you're going to run into where that method would work and this other method I'm about to show you would not work. So take this little shortcut with a grain of salt. But if I divided both sides of this equation by cosine squared, I would get this, wouldn't I? And sine squared over cosine squared is tangent squared, and then I take the square root of each side like this, and it's plus or minus root 3. And so, we go right back to the table. We're like tangent root 3. We still get the 60-degree reference angles, and it's plus or minus, so we still get all 4 of them. It's a little bit quicker way of doing this problem, but this little trick only works in certain cases. The substitution trick in the long run is going to be much better for you. All right, now we're actually on page 9. This is a problem from page 9, problem number 16. And the first thing that you notice is at the top of page 9, the directions now say, take all of your answers from the interval of 0 to 2 pi. So 2 things are the same. The first thing is it's 1 full rotation, since 2 pi and 360 degrees are synonymous, they're equivalent. The other thing that's the same is we'll include the 0, but we won't include the full rotation. So those 2 things are the same. Now the one thing that's different is we are no longer writing our answers in degrees. We now are being asked to write our answers in radians, so keep that in mind. The other thing about the back page that makes it more challenging, these 8 problems on the back, is that they are not factored for you. So you're going to have to do a little bit of work. This is a quadratic, and I'm going to try to factor it into 2 binomials, a quadratic trinomial into 2 binomials. How am I going to do that? Well, how about secant times secant? You get secant squared. And then, if I do 2 times 1, that's the only way to get 2. It's a negative 2 I'm trying to get, so I need a positive and a negative. Because the middle term's negative, the bigger number needs to be negative. There we go. Got it. Okay. What makes secant of x subtract 2? What makes this term right here, what makes that term right there equal to 0? Well, secant of x would have to be 2. Right, to make a 0 there. So what we're really asking is what makes secant of x equal to 2. And on the other side, we're asking what makes secant of x equal to negative 1. Because to get a 0 out of that factor, I would need secant of x to be equal to a negative 1, so that negative 1 plus 1 gave me a 0. So let's go to our table and see what kind of answers we think we can pull from it. We're going to be taking both of these answers from the secant column. Where is secant equal to 2? At 60-degree reference angles. Actually, I guess now we should say pi over 3 reference angles. And the pi over 3 reference angles are pi over 3, 2 pi over 3. Now 3 pi over 3 is pi, so we don't do that one. 4 pi over 3, which is 3 pi over 3 plus pi over 3. And what's 2 pi, which is 6 pi over 3? Subtract pi over 3, 5 pi over 3. So those are your pi over 3 reference angles. Secant is x. So where is x positive? To the right of the y-axis. This is where x's are positive over this way, right? So our answers for that part of the problem, the angles that make secant give us a ratio of 2 are pi over 3 and 5 pi over 3. Now, what about the second part of the problem, where secant equal to negative 1? Well, secant is equal to 1 at 0 radian reference angles. But where is it equal to negative 1? Well, we know secant is an x value, and x is a positive 1 here, and x is a negative 1 back on the negative unit circle. So our only answer there is going to be pi. Okay, you don't want 0 because that's That's a positive one. The only one we're seeking is -1, so you'd have to be on the negative x-axis. And those are your answers. Those are your answers. Pi over 3, pi, and 5 pi over 3i. Just put them in ascending order to get the answer. Okay. That's a good chunk of your problem. I think we did like, what, 6 or 7 of them together? So how about you try the rest of them on your own? Keep working on your verifying. If you're going to be taking the PSAT tomorrow, I think that's awesome. It's the only way to qualify, for that, what is it? Is it the national merit or whatever? And it's one of the greatest things I think a high school student can achieve, so good luck if you're doing that. What we're going to be working on in class tomorrow is just the 6 verifying problems on page 6, a little bit more practice. And the answers, I think a lot of those answers, or at least half of them, are in the back of the book. You could also come in, after school on Wednesday to get some help. Or if you're really stuck on Wednesday night and you email me a problem, I might have time to post a video for you. So, hey, sorry I couldn't be here today. Hopefully this gets you going on the next part of this unit. And just keep working on those verifying problems. I know they can be challenging, but I think you guys will get better and better with every problem that you practice. Peace.